Good morning. So we have one last thing to talk about with functional groups, and then we are going to move on to the very last part of this chapter, and then we can get started on chapter 2. So we had gone over what the different functional groups were. Remember I talked about how there was a carbonyl, which isn't in and of itself a functional group, but rather part of a variety of different carbonyl functional groups. But what we didn't go over here is this further classification. So remember, the really important part about functional groups is you can take an infinite number of compounds, and if they have the same functional group, you can predict that they're all going to react in a very similar way. So that's extremely useful. This further classification of these three functional groups, alcohols, alkyl halides, and amines, are for that exact same purpose. We further classify them as being primary, secondary, or tertiary because we'll have a lot of reactions, for example, where primary alkyl halides will undergo one pathway, whereas secondary and tertiaries will undergo an alternate pathway mechanistically. So that kind of thing happens a lot, which is why it's important to be able to recognize if something is primary, secondary, or tertiary. I'm actually going to start with the amines. They're the easiest ones. The other two are done in a slightly different way. So let's start with amines because I think they're the more intuitive version. So we can start off with ammonia, which technically isn't an amine, it's just its own thing. A nitrogen attached directly to one carbon group. So let's say CH3. This would be considered to be a primary amine because the nitrogen has one carbon group attached. Let me just show you one more example of a primary amine just so there's no confusion. It doesn't matter how long that carbon chain is, there is still only one carbon group directly attached to nitrogen, so that would still be a primary amine. Secondary amine is where we have two carbon groups attached. Again, it doesn't matter what the length of those carbon groups is, just how many direct attachments to nitrogen, so this would be secondary. And then tertiary would be where there are three carbon groups attached, and again, it doesn't matter how long they are, just that there are three of them. Technically, we do have quaternary amines as well. If you had 4 carbon groups attached, this would be something that would have to be cationic because the nitrogen would have a +1 formal charge with 4 bonds, which means it would have to be the cation in some form of an ion pair. There'd have to be some negative charge there, but we can also have quaternary amines. Okay. So now let's look at alkyl halides and alcohols. These are classified in terms of primary, secondary, tertiary in an analogous way to one another, but differently from how we categorize amines. And in part, that's due to the fact that, let's imagine for an alcohol, if we added more than one carbon group to an alcohol, what would the functional group become? It'd become an ether, right? So it would change the functional group entirely if I added more than one group directly to it, whereas these are all amines no matter how many alkyl groups I put on them. But the primary reason they're categorized differently is because doing so is the thing for these functional groups that helps us predict the kinds of reactions that they'll undergo and whether they'll be different from one another. So with alcohols and with alkyl halides, what we're going to do is we're going to look at the carbon that's attached to the alcohol group. And we're going to see, in turn, how many carbons that thing is directly bonded to. So we're not looking at how many things are on the OH, we're looking at how many things are attached to the carbon that's attached to that OH. So technically, methanol is sort of in a class of its own. It's not really primary, secondary, or tertiary. It reacts mostly like a primary, but it's technically not because it doesn't have any carbon groups attached. So if we attach one carbon group here, again, I'm focusing on the carbon that's attached to the oxygen and look at how many carbons that in turn is directly bonded to. That is bonded to hydrogen, hydrogen, carbon. So one carbon, that's a primary alcohol. And just like I did before, I want to show you an example of another primary alcohol that you might get confused as to calling it primary. So let's go again through the rules. We look at the carbon attached to the OH. That's always going to be bonded to 3 other things. 2 of those things is hydrogen, 1 of those things is carbon. Okay, that is not what I meant to draw. Sorry, let me add 1 more carbon here. That does not prove my point. This one will. Again, that carbon in pink is attached to 3 things: hydrogen, hydrogen, and 1 carbon. It doesn't matter that that carbon is in turn bonded to another one, or how long that chain is, how many carbons are on that chain, how many branches there are off that chain. The fact remains that the pink carbon, the one attached to the OH, is directly bonded to only 1 carbon. So that is still a primary alcohol. So no matter how long we make that chain, that's still going to be primary, because we want to look at these direct 3 attachments. Okay, so let's look at a secondary. Oops. So this would be where we have 2 carbons directly attached to the carbon with the OH. And let me again make one that people might categorize differently to make sure we understand the distinction. I'm going to start by looking at the carbon attached to the OH. And I want to see how many carbons are directly attached to that. 1, 2. This carbon out here is irrelevant. That's attached to the next one out. It doesn't matter if there's 100 more carbons along that chain. The only direct attachments to the carbon I have in pink are 2. So that one is secondary. And then we have a tertiary, which would be where that carbon is bonded to 3 carbons directly. And just for simplicity, I'm going to make these all CH3s, but it wouldn't matter how long any of those chains are, this would still be tertiary. So we have the carbon attached to OH, bonded to 1, 2, 3 carbons, so that's tertiary. So alkyl halides are the exact same thing, so I'm not going to go through all of those. We've got, let's say, CH3, CH2, Cl. Maybe I should make this a little more explicit. So why don't you all tell me, is this one primary, secondary, or tertiary? Yeah, so this one is primary. Again, the chain length doesn't matter. We're looking at the carbon, in this case, the one that's attached to the halogen, and we want to see how many carbons that is directly bonded to. It's bonded to hydrogen, hydrogen, and carbon directly. That's only 1 carbon, so that's a primary alkyl halide. So that's, again, another example. It doesn't matter how long that chain is. We want to know how many carbons are directly bonded to the carbon that's attached to the chlorine. And I know that those 2 with alcohols and alkyl halides are certainly less intuitive than the way that we do it with amines, but the way that we categorize those becomes much, much more meaningful in terms of predicting reactivity. So that is why we do it. So to get to secondaries or tertiaries, you could take the alcohol structures I have at the top and just replace it with a halogen. I guess I'll include the lone pairs for now to be complete. Okay. All right, so now we want to look at drawing molecular formulas and constitutional isomers, and what I really want to do